Welcome to Across the Globe. Today we will learn about working with JSON. JSON, short for JavaScript Object Notation, is a lightweight data format that is human-readable and easy for machines to process. It allows data to be structured in a clear and concise manner. To handle JSON data in Python, developers utilize the built-in JSON module. This module provides functions to encode Python data into JSON format and decode JSON data into Python objects. For instance, Python dictionaries can be converted to JSON strings using the json.dumps function, and JSON strings can be transformed into Python dictionaries with the json.loads function. By employing the JSON module, developers can seamlessly work with JSON data in Python, facilitating interactions with APIs or storing data in JSON format. This aids in communication between software systems, streamlining data exchange processes. To convert Python objects to JSON format, such as dictionaries, lists, tuples, and strings, the json.dumps method is used. This function from the JSON module enables you to transform the Python data structures into a JSON formatted string. For instance, consider a scenario where you have a dictionary in Python. If you want to convert this dictionary into JSON format, you can create the dictionary containing the desired key-value pairs and then use the json.dumps method to convert it to a JSON string representation. Subsequently, you can use this JSON formatted string as required in your code or application. In the provided example, a dictionary named person is created with keys like name, age, and city, along with their corresponding values. By employing json.dumps person, the dictionary is converted into a JSON string, which can then be utilized for various purposes like data exchange between systems or storing data in a standard format. To convert JSON data back to Python objects, utilize the json.loads method. This function parses the JSON data into a Python dictionary. After importing the JSON module, you can pass the JSON string to json.loads to obtain the corresponding Python object. For example, import JSON, JSON data, JSON person equal name Alice, age 30, city New York. Converting JSON to dictionary person equals json.loads JSON person, print person name. In the provided scenario, JSON person contains a JSON string representing person data. By applying json.loads JSON person, the JSON string is converted to a Python dictionary stored in the person variable. Subsequently, accessing person name retrieves the value Alice from the dictionary. JSON data can be processed using the json.dump method to write data to a file and the json.load method to read data from a file. For instance, in Python, after importing the JSON module, one can use json.dump to write JSON data to a file by passing the data and file object to the method, encapsulated in a with statement. Conversely, one can utilize json.load to read JSON data from a file by opening the file and using json.load to load the data. Through this procedure, illustrated in the code snippet, JSON data can be effectively stored and retrieved from files, aiding in numerous real-world scenarios, such as saving user preferences in an application or exchanging data between different systems in a standardized JSON format. When working with JSON data in Python, exceptions like JSONDecodeError and JSONEncodeError may occur. To handle these exceptions, you need to use try-except blocks. Here is an example. 1. Import the JSON module. 2. Create a variable JSON data with some JSON data, which may be invalid in this case. 3. Use a try block to attempt decoding the JSON data using json.loads. 4. If the decoding fails due to a JSON decode error, catch the exception and handle it appropriately. For example, by printing an error message along with the exception. By handling these exceptions, your Python program can gracefully manage errors that may arise when working with JSON data. JSON is like a container for information, similar to a lunchbox holding different food items. Each piece of data in JSON is like a different type of food in the lunchbox. The data structure in JSON is like organizing the food items in the lunchbox by category or meal. Manipulating JSON is like rearranging the food items in the lunchbox to create a new meal combination. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster and making learning fun. Go to our website across the globe, www.atg.world. The Python code demonstrates working with JSON data through an analogy of a lunchbox containing various food items. Initially, a lunchbox dictionary is created with key-value pairs representing different food items like the main course, side dish, drink, and dessert. Using the json.dumps method, the lunchbox dictionary is converted into a JSON-formatted string and printed to the console. Next, we organize the lunchbox items into a nested dictionary structure, where all food items are categorized under the key meal. This organized version of the lunchbox is then converted to a JSON string using json.dumps and printed to the console. Furthermore, the code showcases how to manipulate the content of the lunchbox by updating the value of the side dish key. After changing the side dish from chips to salad, the updated lunchbox dictionary is converted back to a JSON string, and the modified representation is printed. This demonstration exemplifies the workflow of converting Python dictionaries into JSON format, organizing JSON data into structured formats, and updating JSON data through dictionary manipulation. The concept depicted in this code sample can be extrapolated to real-world scenarios like data serialization, configuration storage, and communication between web applications using JSON format. JSON is widely used in various industries for data exchange and storage. One example of using JSON is in the e-commerce industry. When an online order is placed, the order details, including customer information, product details, and payment information, are often stored and transmitted in JSON format. This allows different systems within the e-commerce platform, such as inventory management, payment processing, and order fulfillment, to easily access and process the order data. Another application of JSON is in the field of IoT, Internet of Things. IoT devices generate a large amount of data that needs to be efficiently transmitted and stored. JSON is often used to format and organize this data for communication between IoT devices and servers. For instance, sensors in smart homes or industrial equipment can send JSON-formatted data streams containing sensor readings, status updates, or alerts, enabling real-time monitoring and control of IoT devices. In conclusion, JSON plays a crucial role in enabling structured data exchange in various industries, from e-commerce to IoT, facilitating efficient communication and data processing across different platforms and systems. Keep learning, stay curious, and I'll catch you in the next video.